Alright, so you've decided what type of audio system that you're going to design. 8 ohms. Now the question is, you've got a whole bunch of speakers and an amplifier. How do you wire it up properly so you don't damage the amp or the speakers? Well, hey everybody, Nick here for Snap AV. And in this how-to video, we're going to walk through the different types of wiring, parallel, series, and a combination thereof, as well as the different calculations that you need to understand in order to design an efficient system. Let's go ahead and get started. Alright, in the first example, we're going to take a look at a standard 8 ohm amplifier stable to 4 ohms. We're also going to be referring to speakers that will be 8 ohm. Now, in order to wire it in stereo, you simply hook up positive, positive, negative to negative. Pretty simple, right? Well, let's say we want to double up the number of speakers onto this channel, as the example we've drawn out here. Simply wire that in parallel. So you'll double up the amount of wires positive to positive and negative to negative. Now, can this be done? Well, let's take a look at the implications using our calculations. Alright, so here's our calculation to determine total resistance with speakers run in parallel. We have 1 over RT equals 1 over R1 plus 1 over R2, so on and so forth for the number of speakers that you have. R stands for the resistance, and we said each speaker is 8 ohm. So we have 1 over 8 plus 1 over 8. This equals 2 over 8, which equals 1 over 4. To figure out total resistance, we simply flip the equation, so that equals 4 ohms. Now obviously we said this is a 4 ohm stable amp, so we're good to go in this scenario. But let's say we want to add on another speaker. Can we do it? Well, common sense is going to tell us no, but let's take a look at the equation to figure it out anyways. So we'll add on another 8 ohm speaker. This equals 3 over 8. Flipped over is 8 over 3, or 2 and 2/3 ohm. Now, obviously 2 and 2/3 ohm is less than 4 ohms, which means we'll damage the speaker or damage the amplifier if we add on any more speakers. Now let's take a look at wiring in series. Again, we're going to use an amplifier that's 8 ohm and 4 ohm stable. Now, you're going to find series wiring is rarely ever used, but for the purpose of this example, we need to show you so you understand. Now, to wire it, you go positive out of the amplifier to the positive of this first speaker, and then negative out of the first speaker into the positive of the next speaker, and so on and so forth down the line. Out of the last speaker, you're going to wire the negative out to the negative terminal of the amplifier to close the circuit. Let's take a look at the calculations to understand the total resistance of wiring it like this. Alright, so here's our calculation to determine the total resistance for wiring it in series. Very simple. You add up the total resistance of all the speakers that you're using. So since we have 1, 2, 3 speakers at 8 ohm apiece, our total resistance is 24 ohms. Well, wait a minute. I've got an 8 ohm amplifier here and 24 ohms there. What does that mean? Well, let's take a look at how power is calculated. Power equals V squared, or voltage squared, excuse me, over resistance. Now, in this case, voltage is constant. Our resistance is going up with each speaker. Therefore, our power is going down. This simply means we're not going to get near as much amplification out of our speakers, even if our amplifier is high powered. Now, knowing all this, let's take a look at our third and final example of wiring it in parallel and in series. Again, we're going to use an amplifier that's 8 ohm, 4 ohm stable. Now, with the combination wiring, we're going to run these speakers in series, so we'll simply connect positive to negative, and again, with these speakers. Now, since we're also going to run them in parallel, we're going to take the positive terminal of this set of speakers and run it to this channel and connect this series speakers here. Then we're going to take the negative terminal out of this speaker and run it to the negative terminal of the amplifier and then connect this speaker. So now we have these speakers and these speakers in series as well as being in parallel. Now, for our total resistance, with these being in series, we learned that we just sum up the total resistance. So we have 16 ohm here and 16 ohm here. To calculate our total resistance in parallel, as we've already calculated them in series, we have 16 ohm and 16 ohm. We want to do 1 over RT equals 1 over 16 plus 1 over 16. This equals 216 equals 1 over 8. Now again, to figure out the total resistance, we just flip the calculations on both sides. So R over resistance total here equals 8 ohm. Now, as you can see, the benefit is, well, we now have an 8 ohm speaker load on 4 speakers to an 8 ohm amplifier instead of running them down to 4 ohms, which happened when we ran them in parallel. Now, unfortunately, this can get more complex as you get to bigger systems and more speakers, and that's where you'd want to use impedance matching speaker selectors. Now let's say you put a volume control in with a whole bunch of speakers. Now, you did the calculation and your total resistance was 2 ohms. Well, if you look at the back of an episode volume control, you're going to see jumpers for 1x, 2x, 4x, and 8x. The sole purpose is to multiply the total resistance and not damage your amplifier. Well, obviously if you have 2 ohms and we have an 8 ohm stable amplifier, we'll take 4x as our jumper. So 4 times 2 equals 8 ohms. Perfect for our amplifier. Well, that concludes this how-to video on designing an 8 ohm system. We covered wiring in parallel, wiring in series, as well as a combination of parallel and series wiring, in addition to all the calculations and those pesky jumpers on the volume controls. If you do have any questions or any issues while you're in the field, please feel free to call our tech support team. Thank you very much for buying with Snap AV, and as always, happy installing.